Hello, everyone. I'm Victor Perez, and I'm going to talk very briefly about LMOD and conda and how to use them on our machines. I guess most of you are perfectly familiar with them, but just in case, we'll do a brief recap for users of Prinos 2, pointing out the main differences in the configuration of both systems in comparison to Prinos 2. And then I will show a basic usage of both, um, just to give you a basic idea of the capabilities of both systems. Okay, so let's start defining a bit what we are going to talk about for users of our previous machine, for previous cluster. And if you have used Prinos 2, essentially, we have changed the environment module system to LMOD, which is a re-implementation, which is different from the TCL implementation we used in the past. And we have essentially reworked the entire hierarchy in ways that will help us to better manage dependencies, compartmentalization, and so on. But for you, it should be essentially transparent. There's just some extra functionality that I'm going to briefly comment on. And then regarding conda, the configuration is essentially the same as before. It's just that now your environments are going to be stored on data, on the data volume, and group-wide environments are available by default. And if you remember Prinos 2, Mamba was not fully functional. Now we have full Mamba functionality implemented. So let's start with LMOD, and let's very briefly discuss it. It's a Lua implementation of an environment module system which is fully compatible with the TCL classic environment module system that all of you probably know. And what it does is it allows us to pre-configure through files which contain a list of changes to the environment, to the user environment, I mean, some of the variables or other configuration values that we need to be able to run any application. And it is invoked through the module command. And in the LMOD implementation, there's also ML, which is a useful shortcut that does some things as well. The easiest way to interact with it, it's to call the different sub commands of the module command. So for instance, module avail will show you all available modules, which it's not the entire ecosystem of modules, but it is the app level modules, which is to say, those are the modules that are going to load in order to be able to run an application. There are other modules that are loaded behind the scenes as dependencies, or there's a whole hierarchy of them. But in most cases, you will only worry about that app level module, which is going to configure your entire environment. There are also some compiler MPI library toolsets in case you want to compile and run your own applications, if you have your own code. And in general, we have every module is defined by an application name and a version. There's always a default version for each application. So if you just call for the name of the application, for instance, if you say if you call for the Gromax module, it will generally load the latest version that is available on our machine. And just briefly, if you use module minus the avail, then you're only going to see the default modules, which is to say you're going to get a list of the apps and toolsets that we have installed in our machine. To incorporate, to apply the changes defined by any module to your environment, you just have to module load or module add this module. You can load more than one at once, and the tree of dependencies will load automatically. You don't have to load the rest of the modules that are needed to run it. And also, the difference between CPU only and GPU modules is transparent to you, which is to say, you will have different versions of the module available for GPU and CPU environments, but for you, it's exactly the same operation. You just have to load it, and it will load the corresponding version. If you want to unload and undo the changes to your environment, you just have to module unload or module del those modules to revert them. Then you can at any moment show the modules that are currently active for your user using module list. You can see that by default we have a conda module which is loaded always when you log in. The reason that this is contained in a module is that in case your application, for instance, has to use Python, and for some reason the version of Python in the conda-based environment gets in the way, you can unload it. And then there are some other basic operations that you can do, such as you can module purge and remove all the currently active environments from your modules from your environment. You can reset, which is essentially to go back to the default system one. So for instance, right now you will get an empty environment with only conda loaded, whereas if you do module purge, you will also remove conda. You will essentially remove all the modules from your environment. And then you can ask for information about modules, specific modules, using module what is, which gives you a brief description of the module. And you can also do module show to see the details of what that module is going to do when you apply it to your environment. You can also search modules using module spider, which looks at module names using, you can use different approaches, and you can also look for modules by keyword. For instance, you can use module keyword GPU, and you will see only GPU compatible modules. And something that is implemented in LMod and was not implemented in our previous use of TCL modules is the use of collections. You can define collections using your current environment. For instance, if you load several modules that you want to use together, you can save the collection, giving it a name, and then load it all together and so on. But in general, this shouldn't be necessary because our entire configuration of the module environment module system is geared towards single module use. That is, you just load the top level module and everything below it will be automatically loaded. So in general, you should only need to use one module containing everything that is there to use. But in any case, there's also additional functionality that you might want to use. You can check the documentation at the link, and you can always contact us, and we will be happy to help you with whatever additional functionality you want to take advantage of. And with that, let's move on to conda, which I'm sure all of you know it. It is just a cross-platform environment management system, which allows you to use binary package repositories to manage not only software, but also the interdependencies between different pieces of software. And it was started as a Python tool for scientific Python packages, but it has been made language agnostic, so you can find pretty much everything in there, including not only lots of R packages, Perl, other languages, but also system software that might be necessary to encapsulate to run that sort of software, that type of software, such as libraries, compilers, and so on. And it is invoked through the conda command, but we also have Mamba available in Pirineos 3, which is a conda compatible alternative package manager, which has been designed in many ways to overcome some of the bottlenecks of conda in terms of performance, both at the level of resolving environments and resolving dependencies, and at the level of downloading and installation speed, essentially. It's installed side by side with conda. So if you have conda available in Pirineos 3, you have Mamba as well. Now conda, since some versions ago, uses the faster libmamba solver library to resolve dependencies. So if you are using conda now, you're using the core of Mamba. But there's also the Mamba executable, which further implements multi-threading and other little tricks to gain an advantage over conda in terms of performance. In any case, because Mamba doesn't implement absolutely everything that conda does, but if it doesn't, it calls conda as a backup. So you can always replace conda with Mamba. And if there's any problem, it will let you know. In most cases, it will simply use conda to do it if Mamba can do it itself. So from now on, everything that I say about conda, you can just replace with Mamba and you will get a faster execution. This is especially true if you are managing very large environments with many dependencies and you're updating or you are installing many different pieces of software at the same time. Mamba is just much faster. So what's the configuration of conda on Pirineos 3 on our cluster? Essentially, we have that conda module, environment module, that is loaded by default. So you don't need to do anything to have access to conda, but you can unload it if it is needed, because there's some sort of problem with that environment being there. There's only one environment that is offered and shared for all users, which is the base environment, which provides the basic tools to allow conda to run, to install software, and so on. And then the environments, the rest of environments are private, either at user level, individual environments, or at group level, group-wide environments, which are visible for all users in the group. Both are stored on the data volume at slightly different locations. So your personal environments will be located at data, your group, your username, .conda/envs. And for the group, for those that are available for your entire group, it's the same, just without your username in the middle of the path. You can use conda env list to show a list of environments that are available. As you can see in the image, for example, base environment, which is on prod and is shared by all users, is always visible, but then you will have a combination of group environments and individual environments for your user. To activate an environment, you just have to run conda activate, as you know, and conda deactivate. Deactivate the currently active environment. And to see the packages installed inside that environment, you can use conda list without the env that we saw in the previous slide. You can either specify a name of the environment, or if nothing is specified, it just applies to the currently active environment. Then you can create personal environments using conda create -n and the name. You can either create an empty environment using this command, or you can specify the packages you want to be installed at first, up to you. To create a group shared environment, you have to specify the path. So it's really different. You use conda create, but you specify the path with -p, and you have to write, unfortunately, the whole path. But once you've done this, you don't have to call it by the path, because the location of group shared environments will be visible to every user in the group automatically. Then you can also install packages in any of your group's environments. And of course, you can have a greater degree of control by specifying channels and specifying versions of the software. By default, every user has access, or rather, access to the defaults via Conda and Conda Forge channels is configured by default. Otherwise, you will have to manually specify the channel you want to use it, if you want to use it. And you can also update the packages. You can update all the packages in an environment. You can remove some packages. You can delete your whole environment, and so on. And there's also you can use revisions to have a history of modifications in case you want to go back to a previous version, something like that. And that's all. I'm going to show you very briefly an example of this. We're going to create a conda environment, but if you are going to follow along with my colleague Alejandro, who's going to show you a hands-on tutorial on quantum computation in the next section, you might want to create in your own machine. It doesn't have to be on the cluster. It's actually better if you do it on your own machine. You can follow along with the software I'm going to install, just to get your environment ready, because it's going to take a few minutes to install everything. So if you want to follow along, I invite you to open a terminal in your machine and create a conda environment. So I'm going to show you the video doing this. Let me share. Okay. Can you confirm? Can you read my? No. Okay.
Que compartir la presentación y compartir pantalla.
Let me very briefly. Okay. Can you not yet? Okay, let me.
Ahora sí.
No. I'm sorry about this. It's always the demo effect. Okay. Let me do this very quickly. Let me just show you what you have to do. Let me just copy the packages you need, because Okay, well, it's working.
Ahora
Okay, finally working. Okay, so you can see, right? Let's go through it. So I'm starting from my own machine. I'm just connecting to the Pirineos 3, to the cluster. Okay. We can check that conda is available. I'm going to use Mamba instead of conda. I'm going to first create an empty environment. I'm going to call it KiboChem. I'm going to activate it. And then we need to install the following packages. We need Python 3.11. We need Kibo. We need IPyKernel, Matplotlib, KiboJIT, and Jupyter. And we will need to do an extra installation through pip because the version we want for KiboChem is not available. The latest version is not available through conda. So it will take some minute to resolve the dependencies and so on. We get the list of packages to be installed. You can see that it's quite a large environment, complex one. And because we don't want to wait several minutes for it to finish, I'm going to do as I do in TV cooking shows, and I'm going to show you very soon the effect, the final effect of the installation. My colleague is going to use a notebook approach, so that's why I suggest to run it on your local machine instead of on the cluster, because it's much more convenient to have it available with a graphic environment. And then we need to install KiboChem through pip. In recent versions of conda is capable of tracking pip install packages, which is not something it could do before, which is also quite convenient. And those are the two install steps that you have to take to reproduce the environment for the next hands-on. And that's all. I don't know if you have any questions. We just have to wait until pip completes installation, and there are quite a few dependencies through pip as well. That's pretty much it. Okay, so I'm going to leave you with my colleague Alejandro. Oh, okay, sorry. Let me check this. Let me stop. Jose Francisco? Sorry, you're muted.
Okay. Thank you. Well, the thing is, I cannot write on the chat. I don't know. I'm not allowed to write on the chat, so basically, I'm just raising my hand to ask a question.
Okay.
You meant because I get lost because you mentioned you were going to use local. I mean, you are installing in the
yes,
Pirineos, but you are going to use it local.
I show how to do it on Pirineos, but I suggest that if you want to follow along for the demonstration that my colleague is going to do, you do it on local because it's going to be faster. So just reproduce the environment in your local machine if you have conda installed, just because it's much more convenient.
Okay. No, because I was thinking because there is like a way in Jupyter Notebook that you can connect, and I was thinking you were going to do something like that.
You can do that, but I think it's probably I mean, since I can always show you, and it's probably going to be a bit more difficult to make it work. Let's keep it simple. Let's do it locally.
Okay, thank you.